Okay, the live stream is starting. Yeah, we start from one-dimensional motion, and but I think one dimension. Oh. Not here. Not this one. We start from the lecture one-dimensional motion. One-dimensional motion, I think, we are introducing the basic ways to describe motions. And here are several important properties. So we start from distance. How do we define distance? And velocity. Velocity is quite intuitive. I don't think we need any explanation. But acceleration, okay, so distance, velocity, acceleration. And we have to give definitions to it. And then we have another mission. We have to use a mathematical language to describe them. So that's why we need to learn derivative. We need to learn okay, we need to learn derivative, and then we have to use the concept in derivatives to define how to measure curves, slopes, and curvature. Okay, so we have to learn how to operate the steps in derivative, and then we have to look at the graphs, and then we have to look at the shape of your curves. And by recognizing the slope and by recognizing the curvature, you have to tell something about the velocity and acceleration of your moving objects. Okay, so this is our goal. I think the most difficult thing is about the derivative, and I think the curves, slopes, and curvature is quite new for someone, for some of our students. Okay, so this is we start from a example, and just imagine this is a map of our campus. And please just imagine that you are in the parking lot for the scooters. So it's at the back gate of our campus, and you're here, and you're heading to the pancake house of our campus. 所以你现在是在后门，然后你现在要去小木桶。And if you are familiar with our campus enough, and you can imagine someone is monitoring your motions, and maybe he just monitors your movements every 10 seconds, and then every 10 seconds it records your position. So if you look at the position, can you probably imagine how fast your movement is? Can you imagine how, for example, if you are walking, or if you're running, or if you're doing some turns or changes? So here I can try to imagine that when you are starting to walk, and then now you are walking, you are just walking in a relaxed pace, and maybe something happens, so you speed up, so you can see the distance between the points, and it's a sign that you are speeding up. And then maybe something happens here. For example, you get to the pancake house, you want to get a pancake, but you suddenly realize that you don't have any money. So maybe you just go to the back side, and then go to the post office, and go to the ATM, take some money, and then come back here to pay for your pancake. So when you're looking at the positions, and when you look at the dots, and look at the distribution, you can have a lot of imagination about your movements. Okay. And here is the data graph. If I do a very, very serious measurement about your movement, so this is the time when you start, and you start to move on, you speed up, you get to the door of the little wooden house pancake, and then you turn back. And this is the position. So I measure your position in meters. This is 0, and then 15 and 100 meters, and go on and go on and go on. So this is my record. And now what can I say about the record? So first we have to define what is displacement? So this is a clear definition, and displacement is defined by your final position minus initial position. We care about the starting point and we care about the final point, but we don't care about what's happening in the middle. So please be careful about displacement and on the graphs and usually especially on vector graphs, and the displacement is very important. You have to remember we only care about the starting point and the final point, but we don't care about things happening in between. 这个是中文是位移。Okay, and then go on. So if we look at this, we try to look at the same thing on our data graphs, and you can see that the displacement is x final minus x initial. This is x final, this is x initial. So delta x is simply the deviation between them. Deviation is the right word. Okay. Anyway, but this is 424.5 meters. So this is the distance between the scooter parking lot and the pancake house in our school. 我们校园的长度大概是424.5公尺。我在 Google Map 上面留的。Okay, this is the definition of displacement and how we operate it in data. And then we go on with the second thing. So what about velocity? And we really care about displacement because then we go to the definition of velocity if we want to operate with mathematics, especially in calculus. And then we have to make definitions like this to make the mathematics works. So the velocity is defined by the displacement divided by the time interval. 就是velocity 速度是它的定义，就是你的位移除以时间差。Okay, so this is the final position, initial position, final time, initial time. And if you look at it on the graph, then it looks like the delta x is on the y-axis, the delta t is on the x-axis. So we just simply pick the difference in position and the difference in time, then you get the velocity. Okay. And then we go on. So that's zoom in. Let's zoom in into the curve, just like you're playing a touch screen. 所以从上张图到这边图，大家注意哦，我们要做的事情就是 zoom in， 就放大，然后你只看那个 curve 的那个点。So now you are staring at just the little point on the curve. For example, let's look at this point. I would like to know the velocity here, right here, on this time, no other places, just this place. And now you can make a new definition. So the velocity on this point, delta x over delta t, this is not changing, but we could have another symbol in the front telling your reader, now I'm taking a limitation as if the time interval is very, very, very small. So this is what we are doing on the picture. And now we can change to another symbol system. This is the symbol system in calculus. So a lot of things, a lot of description here turns into dx over dt. So now we are getting into derivatives. 从这边开始，我们进入微分的范围了。好，那这边其实主要是跟大家介绍符号跟定义。有点烦，请忍耐一下。Okay, then we go on. Okay, go on. Now we are defining one thing. So let's look at different positions on the curve. So we have a curve with a very free shape like this. And then if you do the derivative on different points on the curve, you can see that the delta x over delta t is giving you a straight line actually. So if you just draw the straight line on each point, And you can see the stiffness of the slope. 大家可以看一下啊，就是如果说我们刚刚算的是那个在瞬间的速度嘛，然后那个速度，大家记不记得我们刚才画一个三角形？然后呢，你就抓这两个点，然后画一条直线。好，然后你看一下那条直线它的斜度，它有多斜。So this is a slope. The number is positive, and then this is this is just a slope. And then we do the comparison later. So this is another slope with the largest stiffness, positive, but the slope here is larger than this one. Okay, and on this point, this is the turning point when you are turning your direction. And on exactly the point when you turn your direction, you get slope is equal to 0. Seems like on this time, you don't have any velocity. Okay, and then you turn back, your direction changed, and then here you can see your velocity changed into a negative number, and I have a negative slope. So you can see a lot of information on the graph. You can see the stiffness of the slope, and then you can see if it's positive or negative, and then you can say a lot of things. 那所以大家可以知道说，我们现在你如果就丢给你一张图了，然后你要判断说，哇塞，这个人在干嘛？对，那你现在就是你可以看哦，就是每一个点你大概估算一下，就是它的斜率是多少，那斜率就会等于它的速度。那你看一下哦，它的速度是大还是小？它是往正的方向移动还是往负的方向移动？所以你光看这些小地方，你就可以解读很多事情了。对，那我觉得我们这个解读的能力是蛮重要的。So this is how you read a graph. Okay, and then here is a big definition. This is the important thing. Derivative. So derivative is defined by this one. It's defined by a small amount of change of x. This is your target in a small duration of time. So this is your x is changing with time. This is the independent variable. This is the dependent variable. 自变数、因变数，这个是函数。如果在数学的课程里面的话，应该会这样子写，而且还会在 x 的后面加括号，再加一个 t。通常微积分跟普通物理的进度应该会平行，会一起，所以大家可以把我讲的东西跟你在微积分课上面的再对照。微积分课会再讲得更细一点。真的是 definition of derivative. I think the most important word is the change, a small amount of change in a certain duration of time. Okay, and then we go on. I think we cannot go so far because we are close to the end of the lecture. Okay, so here is a comparison between the two graphs. We just introduced how to calculate velocity. So we have the position graph on the top, and if you calculate the velocity for every point on the graph, and this is finally what you have. So between the time here and this one, the velocity is actually not changing, and from here, from this time to here to 200, your velocity is getting faster and faster and faster, but in a linear trend. So up to here. And up to here, seems like you just recognize that something happened, and suddenly you are changing the direction of your velocity, and you suddenly change the amount of the strength of your velocity. So you can see that now the velocity is getting from something like 4.5 into 6, but the direction suddenly changed to a negative direction, and your velocity is getting this way. Okay, the velocity is actually not changing, but you can see your position is somehow this is like you are slowing down, you stop somewhere and you turn back. So please just pay attention to the trend of the curves. And you can see that you can maybe make a challenge for yourself and try to see if you can see the velocity is just simply on the graph here. 那我觉得大家看这个图的时候，你可以给自己一点小小的训练，就是呢，你能不能看着上面那张图，你就可以讲出它的速度是多少？对，那你可以应用一下我们第一堂课讲的，就是 you can apply the knowledge that I introduced in the first section. So the linear curve, the parabolic curves, right? So they are just the combinations of the three types of curves. And the derivative of the three different trains, and then you have a velocity. This is a constant velocity. This is the positive velocity and negative velocity. Okay. And then actually, if you want to, you can do the calculation by yourself. Okay. And I don't think I will have enough time for acceleration, so we go on with the acceleration in the next lecture. Okay? 那我觉得我们今天没有时间再讲加速度了，我们下个礼拜从加速度开始。今天上课到这边。